The first problem is about filling in a Sudoku puzzle using a random number table to fill in the blank squares. And if you're unfamiliar with Sudoku, it looks like this. Each row has to have the numbers 1 through 9 just one time. Each column has the numbers 9 just one time, 1 through 9 one time. And each box has the numbers 1 through 9 listed just one time. So a random number table would not be good at all because you could end up with more than one of the same number in a box or a row or a column because everything's just random. Sudoku takes logic and a thought process. Randomness doesn't work to fill it in correctly. Question 2 is about Alicia downloading 10 different puzzles, finding 10 friends to do them, and then gathering the completion times. And so she's trying to determine how long it takes a person to do a puzzle. Some of the problems with this is it's not clear that all the puzzles are going to be the same difficulty level. Some Sudokus are much harder than the other, so that will throw off the times of different people doing them. If somebody has an easy one and somebody has an impossible one. Some of the friends could have different experience with Sudokus. So somebody who's really, really good could go through it in a minute. Somebody else takes 2 hours because they're new to it. So that doesn't really help you see the average time it takes a person to do a puzzle. And they're also volunteers, so you may only have the people volunteer who really like Sudokus, and then you don't get to see how well people do who don't like Sudokus. And if you're trying to figure out the time it takes someone to complete a Sudoku, you need a random sample, people from all categories, not just random volunteers who want to do it. Also, it's not really specified in the problem how the timing is going to be conducted, who's going to check to see if the puzzle's correct or not. And if people are just self-timing themselves, that could really vary from person to person. It might not be accurate. So there needs to be a lot more explanation of how the survey is going to be conducted, even if she did have the other items lined up with people, with random people of varying backgrounds and all the puzzles the same difficulty. It would still need to be explained how is she going to conduct the timing and make sure the things are correct. A little confusion on this problem. A and B right here in capital letters, you don't have to answer those. Those are part of the problem. These are the survey questions you're asking the work study students. So those students are going to answer these two questions. And now your job is to answer A through, A through G about this survey that has these two questions. So little a here says, it describes the way to break people into groups here and what kind of sampling technique are you using. And this is stratified. And if you look at page 16, it falls directly into the category of stratified. Actually 16 and 17. 17 has a nice yellow box breakdown. And you can see this is stratified. B, describe the individuals. It's students on the campus who have work-study jobs. We're only interviewing people, surveying people with work-study jobs. What's the variable for question A? So what's the variable for this question up here? And it's how many hours are scheduled. That's going to vary from person to person. And that is a quantitative variable. It's a number. And this is on the ratio level. So looking at the different levels, they would be on page 7. There's a great breakdown, and the ratio says the data can be arranged in order, so you can definitely arrange in order how many hours people work. And in addition, the difference between the values and the ratio of values have meaning. So yeah, if somebody works 7 hours and somebody else only works 3 hours, then that difference makes sense. This person worked 4 more hours than the other person. Ratios also make sense. If someone worked 8 hours and somebody else worked 4 hours, this person, 8 over 4 is 2 to 1. Yeah, that person worked twice as much as the other person. Ratios also have a true zero. In this case, if you work 0 hours, that is the smallest, the least you can do. So someone could have a work-study job but work 0 hours. They're just not on the schedule. So this is a ratio, level of measurement. The variable for B, we're trying to measure the rating of applicability of work experience to future employment. So that's what's going to vary from person to person. How applicable is the work experience to future employment? This is qualitative and ordinal. So if you look on page 5, the difference between quantitative and qualitative. So this is definitely falls into the qualitative category, and I know we're giving numbers here for this question, either 1, 2, or 3. But it doesn't make sense to add those numbers or average those numbers. They're not acting as real numbers in a sense. They're more categories. 1 stands for the category not at all, 2 is the category somewhat, and 3 is the category very. So this is a qualitative. And again on page 7, the level of measurement, it falls into the ordinal category. Yeah, we can arrange them in order. Put the 1s in front of the 2s and then the 3s next. You can arrange those in order. But the differences between data values don't really have meaning. You wouldn't want to subtract those to figure out. I mean, it means nothing. 2 minus 1, someone who says somewhat is 1 more than someone who says not at all. That doesn't make sense. These numbers are just categories, basically. So it doesn't make sense to go to the interval level where the differences between those numbers mean anything. So we're at the ordinal level. For E, the proportion of the responses 3, is that a statistic or a parameter? It's going to be a statistic because we're not going to have data from the entire population. There's always somebody who doesn't respond to a survey. And you can go back to page 5 on the bottom of the page. It talks about the difference between a population parameter and a sample statistic. So we just have a statistic here. For F, suppose only 40% of the students you selected for the sample give a response. The non-response rate then would be 60%. And this could be biased. It could introduce bias into the survey because there could be a reason that those 60% are all choosing not to participate. And so if those 60% have a common characteristic such as not working many hours, and then the 40% are those who work a lot, then your survey is going to come back that everybody works a bunch. Well, really just all the people who didn't work a lot sat out and didn't participate. So there's going to be extreme bias there because those 60% aren't represented in the survey. And it would not be appropriate to generalize the results to all work-study students in the nation. We've only looked at one campus, one school here. Things could be very different in different states, at different schools, and so this would not be good to generalize. So on question 4, a radio talk show host asks people to call in and respond to a question. Is the candidate who spends the most on a campaign most likely to win? So what's the implied population? It's the opinions of all the listeners. So all the listeners to that radio show. The variable is going to be the given opinion of a specific caller. So that's what's going to vary from person to person, their opinion. Can you detect bias? Yes. A major reason for the bias is this is a voluntary response. People aren't required to respond. And if you look at the pitfalls of a survey on page 25, the pitfalls of a survey, voluntary response is listed. And It can definitely introduce bias because individuals with strong feelings about a subject are more likely than others to respond. So it can be interesting but not reflective of the population. Another bias can be some people are at different stages of their day when this question is being asked. Maybe they're at work and they can't call in, or they're on their commute and they don't want to be on their phone. So only certain people even have the option to respond and call in. So that's going to produce bias as well. All right, so we know 30% of viewers have TiVo, and we want to simulate, we're designing a simulation of how a random sample of 7 station viewers would respond to the question, do you have TiVo? All right, so we know 30% have TiVo. Here's how we could set this up. A random number table has the numbers 0 through 9, which is 10 different numbers, listed in random order. And if we want 30% of those numbers to correspond to TiVo, because we know 30% of people have TiVo, we just need to pick any 3 numbers, because 3 out of 10 is 30%. I picked 7, 8, 9. You could pick any 3 as long as it's 3. So these numbers are going to represent TiVo. The other numbers represent no TiVo. And so here we have 30% of our numbers representing TiVo. And now you need to go to a random number table. There's a table on the back of your book in the appendix, a random number table. It's on appendix page A1. And this was created by a computer. It's just completely random numbers. And you're supposed to just start anywhere in the table, maybe drop a pin on the table and see where the point of the pin ends up, or randomly pick a starting point. Let's say we start right here. The problem said we ask 7 people. We're supposed to simulate asking 7 people whether they have TiVo or not. So if I start right here, I have the responses 5133306. 5133306. Those are my 7 responses. So let's type those in here. 5133306. So if I ask 7 people, this is my simulation. It's like I went to 7 houses, and here's what their responses were. No TiVo, no TiVo, no TiVo, no TiVo, no, no, no. So in that simulation, I actually had 7 no's in a row, which is possible. Only 30% of people have TiVo. You could go to 7 houses and get 7 no's. So we're simulating here. Let's do a new simulation. Let's say I just started right here. 4846465. So this one we have 4846465. Let me make sure I didn't mess that up. 4846465. Right. Okay. So now I went to 7 different houses, running that simulation again. My answers this time would be no TiVo, yes. This is one of the people who has TiVo. So no, yes, no, 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 no. So this is how you would set up a simulation of surveying people whether they have TiVo or not, given that you already know only 30% have. So pick your own random starting point in the back of the book in that appendix and see what your responses are to the survey.